if scientists are dealing with some colored solution in a video, it's because there's a photographer there and it doesn't really look that pretty to be pipetting clear liquids, which is what we do most of the time. But this is actually Blue Dextran, and what we're going to be doing is using it to figure out the void volume in our Size Exclusion Chromatography column, or sometimes this is referred to as gel filtration. These columns work in that they have these beads that have these little pores or secret tunnels, and then the big stuff can't go through all the beads, so they get all the pores, and so they have a shorter distance to travel, whereas the small stuff has to go through all the pores, the secret tunnels, so they travel slower. So the void volume is the volume that doesn't go through any of those pores. So instead of seeing those little porous beads, it sees something more like a marble jar. And so it just goes all the way around. That void volume is important for predicting, kind of estimating the molecular weight of a protein. And so the bigger things are going to travel faster, the littler things are going to travel slower. And you can actually make a standard curve, a calibration curve, that's going to allow you to relate the elution volume, so how long basically it took to get through the column, to the size of the protein. And so it's only an estimation because it's not just the molecular weight, it's not just the number of amino acids and the weight of those amino acids, so it's not just how long it is and how heavy it is, but how the protein is folded up. So we can talk about like hydrodynamic radius and stuff, where if a protein it can be small, but it acts like it's really big because it's like man-spreaded and it's taken up a bunch of space, and so then it's going to run like it's bigger even though it's not. So it's not exactly the molecular weight, but you can estimate it, and you use standards of proteins that are nice and globular and behave like their molecular weight, and then you can compare the elution volume of a protein that you're interested in to the elution volumes of those standards. But you have to basically make a curve where you're comparing the elution volume of a protein to the void volume of your column. And so the void volume, that's the liquid that's going around all of the different resin, all the different beads, and so we need to calculate that. The way that we're going to determine this is with this Blue Dextran, and so this is a polysaccharide, so a sugar, and it's a really, really big sugar, and it's attached to a blue dye. So it's covalently attached, so it's permanently linked to that blue dye. When I say big, I mean really big. So sometimes you'll see it called like Blue Dextran 2000. That 2000 is indicating that it's 2000 kilodaltons or 2 megadaltons. Really, really, really big sucker. So this column that we're using, the SuperDex 200 increased 10-100 or 10-300 GL. I need to get better at saying that fast. It's like a really, really long name. But basically the size exclusion column that we're using, it has a fractionating range, so the range in which you can actually like separate things, of I think it's like 10 to 600 kilodaltons. And we're talking 2000 kilodaltons here, so we're way above that exclusion limit, which means that this Blue Dextran is just going to go around all of the different beads and it's going to come out. And the volume at which they come out or elute from the column is going to be your void volume. And so we talk in terms of volumes, although you might be thinking practically in terms of time, because the time is going to depend on the rate of flow through the column, but the elution volume should remain consistent no matter what flow rate you're running things at. And it should be related to the molecular weight of your molecule. And typically this is going to be a protein, but in the case of things like Blue Dextran, it's not. And we're going to be able to see it come out, so it should also be absorbing the 280 light, so we should be able to see it in our detector. Additionally, we can kind of visually look at it. And the reason why it's helpful to be able to visually look at it too is not just that it's pretty because it's blue, but that it's going to allow you to see if your column is packed well. So if there are problems with the column packing, then you will see like it'll look weird and wonky and stuff. You want to see a nice crisp line moving through your column and then coming out, and the volume at which it comes out, the volume at which it elutes, is your void volume. And then you go and you find the elution volumes for the proteins you're interested in, and then you make your calibration curve, and then you make your calibration curve with your standards, and then you take the protein that you're interested in and compare it to those. And so Alice is now going to inject our Blue Dextran. We'll start our method running and keep an eye on it and see when that comes out. Not a paid endorsement at all, but we're basically using this kit from Sigma, and it's got the Blue Dextran, and we are injecting at 2 mg per mil, and the vial has 50 mgs, and so we made a solution of 10 mgs per mil and then diluted that. Okay, let's go for it. So we're good, we're in manual inject mode. Alice is gonna go and inject it into the valve. Yay! Okay, awesome. And so let's go and see how it goes. It is now going onto our column. So what is the void volume of our column?
8.62.
Yes, 8.62 milliliters. Nice work.